Okay, so whatever you have completed on your pre-assessment, you'll turn that into the front black tray on your way out. We are going to open our blue prime books to page 36. So on Wednesday, we did our battleship activity, and we practiced graphing linear equations and seeing where they crossed. Yesterday, we were reintroduced to the three methods that we have for solving systems of equations. That was 1, we had graphing, 2, we had substitution, and our third one was elimination. Woo. So today we're going to work on a few problems all together so we can remember exactly how we do those. So at the top of page 36, we have two linear equations. We have 2x plus 3y equals 9, and negative 4x minus 6y equals negative 18. And the first thing we want to do is solve it graphically. So what do we want to do to that top equation so we know how to graph it? What kind of form do we want it in? Yeah, we're going to want to put it in y equals mx plus b form. So if we want to get that y alone, what are we going to do first? We got to move everything. Yeah, we're going to move the x. So we're going to subtract 2x from both sides. But to get it into y equals mx plus b form, we need that y alone. So what do we have to do to get that y alone? Yeah, we're going to divide everything by 3. And that gives us the equation y equals negative 2/3 x plus 3. And we want to graph that. So where do we start if we're going to graph that? Yeah, we're going to start at our y-intercept, which is 3. And then where do I move from there?
Down to the left.
Okay, so it's a negative 2 over 3. We have down 2. Which way do we move?
No.
To the right 3, yeah. So we're going to go down 2 over 3. And we'll keep doing that until we can't. And then we'll go back to the other side and do it there. And then I'm going to want to do the exact same thing for that bottom equation. I want to put that into y equals mx plus b form as well. So what do I do first?
Check the x. Or add.
Yeah, so we want to move that x. We're going to add 4x. Tristan, do you guys have questions?
Yeah. No, I have a question.
Okay.
Okay, so how do you know, like, okay, if it's negative, I thought, like, a negative graph goes like this to the left, so what? But this is a negative 2, so.
Okay, so if we have a positive slope, we're moving up and then to the right. Yeah? If we have a negative slope, you can choose if you want to move down 2 to the right 3 or up 2 and to the left 3. It's going to give you the same thing, but you have to switch one direction. So if we have a negative 2, instead of going up, we go down. But we have a positive 3 still, and that's going to keep going right.
So you divided it by negative 3, so you want to go to the left?
So if I divided by negative 3, if we wanted to, if we had 2 over negative 3, you can assign that negative to either one that makes sense to you. But that negative is going to reverse the direction that we usually go. So if we have 2 over negative 3, then you would go up 2, left 3.
But if you, so you always go through the right, so like, but it just depends on if you're going out or down.
But you said you knew that this negative slope was going to this way, right? Down the page. So that's a good way to check it. If you know it's a negative slope, it should be going from the top left down to the right.
Tristan, what happens if you divide a negative by a negative?
Then it turns to positive.
It turns into a positive. So if you go down and left, that's the negative direction for both the y and the x. It turns it into a positive slope. That's why only one of them would be reversed.
Also, down is like a negative.
Yes, because if you go down, you're going into the negatives on the y-axis. If you go left, you're going into the negatives on the x-axis.
Okay. Thank you.
I'm going to move this one more over. Okay, so with our second equation, we're just adding the 4x right now. We have negative 6y equals 4x minus 18. What do we need to do to get that y alone? Divide by negative 6, yes. And we're going to divide everything by that and get y equals... What's 4 over negative 6 simplified to? 2/3, yeah, a negative 2/3. And negative 18 divided by negative 6 will give us a positive 3. You have a question? So 4 divided by 6, 18 divided by 6. Yeah, it's going to be the same thing.
It's the same thing.
Yeah. Okay, so how do we graph that second equation? It's the same exact way. Yeah, we're going to start at 3. We're going to go down 2 over 3 for our slope.
You want us to graph it? You want us to graph it in a different color?
You should graph it however it makes sense to you. If you're going to look back at it, you should know what your notes mean. So part C says, what do we notice about those lines? And Tristan just said, they're the exact same line, yeah. So part B, we're going to solve it algebraically. So we have 2 algebraic ways to solve systems of equations. We have substitution and linear combination or elimination. For this one, I'm going to use elimination, but we can use either one for any systems of equations. So what does it mean to eliminate something? Yeah, we get rid of it. So when we're doing an elimination method, we're trying to get rid of one of the variables.
You can multiply. Oh, you want us to say?
Sure.
Oh, you can multiply the 2x by negative 2. No, just kidding. By 2, but you have to multiply everything by 2, so then it would be 4x plus 6y.
Okay. Yes.
What, doesn't that cancel?
So Tristan,
Oh, it cancels out everything.
yeah, so take it step by step with me. Which variable do you want to cancel right now?
Well, I was going to cancel x.
Great, stop there. You're going to cancel the x. So you wanted to multiply the top equation by 2. Why?
Because 2 times 2 is 4, and negative 4 cancels out with 4.
Exactly. So we're going to multiply everything up there by 2. And that's going to give us 4x plus 6y equals 18. When we add those two equations together, just like Tristan was saying, we're going to end up having everything cancel out. And we get 0 equals 0. Is 0 equals 0 a true statement? Yes, that is a true statement. Do we have an x value and a y value? Do we have an x equals a number and a y equals a number? No, we don't. So we don't have just one solution. We could put any single x in here and get a y value that would be the same for both lines. So when we have 0 equals 0, which is a true statement, we have infinitely many solutions. So what that means is if I could choose any x value, I could choose 0 for both equations, and I would get the same y value. If I chose negative 1,000 for x, I would get the same y value. So I have infinitely many solutions. Down in part D, the lines share every point. So there are infinitely many solutions. And then in this class, we're just going to skip part E on this that talks about consistency and dependency because we're not going to deal with that in this class. Okay, let's turn to the next page and do another one. So, what do we want to do so we can graph those equations? What do we want to move? We want to put them in slope-intercept form. So how do we put the first one into slope-intercept form? Subtract the x from both sides. Then we have negative 2y equals negative x plus 8. What do we do to get the y alone? Divide everything by negative 2. That's going to simplify to positive 1/2 x minus 4. Where do we start on the graph? Negative 4 is our y-intercept. And where do I move from there? Up 1 and right 2, yes. And then we're going to do the same thing for our other equation. 3x minus 6y equals 6. What do we want to do first?
We can add 6y.
We can add 6y. What if I want to keep the y on the left because I have y equals mx plus b as my equation.
You can subtract it. Oh, just kidding. You can just subtract the 3x.
Yeah, you totally could do the other way if you wanted to move the y over there. I'm just going to keep it the same way we've been doing it. So now I have negative 6y equals negative 3x plus 6. What do I do to get the y alone?
Divide it by negative 6.
Yeah, we divide both sides by negative 6. And what does that simplify to?
1/2 x plus 1.
1/2 x. Is it plus 1?
Minus 1.
There you go.
Why is it minus 1? Isn't a positive divided by a negative?
Yes, it is a positive divided by a negative. Is that going to be a positive or a negative?
That's good.
Okay. Y equals 1/2 x minus 1. Where do we start? Negative 1. How do I move from that negative 1? Up one and to the right two. Thank you. What do we notice about those two lines? Those lines are parallel. Okay, now it asks us to solve it algebraically. I'm going to use the same method here that we used before. We're going to use elimination. But we totally could use substitution too.
It's a -3 though.
Is it?
Yes, -3.
So when we want to get rid of that. Okay, so if we want to eliminate a variable here, which variable should we eliminate? We can do either one. You want to do x? What's that? Yeah, okay, so we're going to eliminate our x variable, and to do that, we're going to multiply by -3. Sean, why -3? Yeah, so we had +3x on the second one, and we want to get the top one to be -3x. So we have -3x plus 6y equals -24, and 3x minus 6y equals 6. What's going to happen when we add those two together? Yeah, so the x's are going to cancel just like we wanted, and the y's are going to cancel too. And -18. So does 0 equal -18? No, that is a false statement. So if we have a false statement and we don't have x and y values, and we see that our lines are parallel from the graph, how many solutions do we have? No solutions. So the lines do not intersect. They never cross. And because of that, we don't have any solutions. Okay, again, we're going to skip part E because we don't need to worry about dependency and consistency in this class. And we'll move on to the next page. Okay, what do we do to get these into a form we can graph? Yeah, we're always going to want to move that into slope-intercept form. How do we start putting that into slope-intercept form? Subtract x or?
Add x?
Yeah, we're going to add x because it's negative. So we have y equals x minus 2. Do we have to do anything else to get it in y equals mx plus b form? No, we're good. So where do I start on the graph?
-2.
Yeah, exactly. -2 is our y-intercept. How do I move from here? Up 1, right 1, yeah. Now we want to get the second one into that form too.
Subtract 3x.
Thank you. Yes, we're going to subtract 3x from both sides. Where do we start on the graph if we are graphing that? +2, that's our y-intercept. Where do we move from there? Up 3 and left 1? Nice, yeah. Which is also the same as moving down 3 and to the right 1. What do we notice about those two lines?
They intersect.
Tristan? They intersect, yeah. How many times do they intersect?
Just one.
Just once. I'm going to circle where they intersect right there. And I know that when two lines intersect, that's going to be a solution. So if I'm solving it graphically, I'm going to just find where my two lines cross, and that point is my solution. And we said we noticed that they cross once. All right. Now we're going to solve it algebraically. So again, we can use any of our methods for any systems of linear equations. We just used elimination twice, so I'm going to use substitution, but we could also do the same thing we've been doing if we wanted to. What does it mean when we substitute something? Yeah, we plug it in or we replace it. So right now we have two equations, y equals x minus 2 and y equals negative 3x plus 2. If I wanted to substitute one of those in, I would look at one and say, the red equation says y equals x minus 2. I'm going to take that whole side, x minus 2, and put it in for that y. So it's going to end up looking like x minus 2 equals negative 3x plus 2. How many variables do I have in this line?
2. Like 1.
How many? Which variable do I have in this line? Yeah, so I just have that one variable. That's what we're going to solve for now. So what would I do to solve for x? So I heard add 3 or subtract x. I want to get all of my x terms to one side. So I could subtract x from both sides. Or you could move the negative 3x by adding 3x to the other side. But it works either way. So if I subtract an x from both sides, I'll end up with a negative 2 equals, what's negative 3x minus x? Negative 4x, and I'll bring that plus 2 down. What else do I have to do to get my x alone? Subtract 2 from both sides, which leaves me with negative 4x and negative 4. What's the last thing I need to do? Divide by what? By -4 on both sides. So now I have x equals 1. And I want to find what my y is. What do I do with x equals 1 to find y?
Plug it in.
Plug it in. Where am I plugging it in?
Y equals x minus 2.
Okay. We can plug it into any one of these forms. So y equals x minus 2 is a perfect choice because they all are. So y equals, we're going to plug that x equals 1 in, minus 2. What would y equal? -1. How many solutions do we have? Just one, yeah. So we're going to write our solution as our ordered pair, 1, -1. Is that the same point that we found on the graph? Yeah. So if we solve this graphically with substitution or with elimination, we're always going to get the same answer. And the bottom we had the lines intersect at 1, 1, and that's our only solution. All right. Our homework. Sorry, Kyla, I'll go back. Our homework for the weekend is a discussion post on Canvas. I introduced it yesterday. It has 4 questions. You answer all 4 questions in your first post. After you post that, you'll be able to see everyone else's responses, and you need to comment on at least 2 other people's posts. That will be due on Tuesday.
There was a really good question in third period as far as like what kind of comments you leave, because valuable